Hello, today we're going to learn the laws of logs. We have the logarithm of a product, the logarithm of a quotient, x divided by y, and the logarithm of a power, x, some argument to a power here. And we want to kind of think about it a little bit in terms of what we did with our exponents. Remember, when we had exponents, when you multiplied two numbers with the same base, you could add the exponents. So if I'm multiplying my arguments, I actually can add two logs. When I divided with my exponents, right, I subtracted my exponents. And when I had a power raised to a power, I multiplied it. So you can kind of see the connection between our exponents and our logs. But that's not good enough. Let's go through and prove that these are true. We're going to start off with the idea of just letting log base a of x equals some variable. Let's call it m. And log base a of y is equals to n. So basically, we've just called this m and this n. Okay? And we want to mess with it. So first of all, we're going to start with these two ideas, and we are going to say, well, if I know I have it in logarithmic form, I can then change it to exponential form by looping it, right? The base of my log to the m equals x. The base of my log becomes the base of my exponent to the n equals y. And now if I look at taking x times y, I can multiply those together, and so then this becomes log base a, and instead of writing x, I write a to the m, and instead of writing y, I write a to the n. And now because we have the idea that I have the same base, and I am multiplying, so I'm looking just at the exponentials, so a to the m times a to the n. I have the same base. I'm not paying any attention to this log base a, but I know that the rule said if you multiply, you add your exponents. All right, and then a log property we learned yesterday was, or maybe not yesterday, but a while back, we have log base a of a to anything always equals the anything. So therefore, this equals m plus n, and we let m equal log base a of x, and we let n equal log base a of y. And so we have shown that log base a of xy is the same thing as log base a of x plus log base a of y. Okay, the proof for division is very similar. If you think you want to try it, go ahead and pause and start the same process I just did. All right, so again, you see that we have division here. So we're just going to start off by calling this m and this n just like we did last time. Turn it exponential, so a to the m equals x, a to the n equals y. And now when I do division, instead of writing x and y, I'm going to write a to the m divided by a to the n. I'm going to use my exponent rules that we learned. If I'm dividing with the same base, that means I just go ahead and subtract my exponents. And then again, from our property we learned a while ago, log base a of a to the n is just going to be n. So we know that's just going to be equal to m minus n. And we called m log base a of x. And we called n log base a of y. And so we have proved that log base a of x over y is the same thing as taking the difference of the logs. All right, one more property to prove. Start out with the same idea. We're just going to let log base a of x equal m. Okay, so I'm just going to write that as m. And I need to then prove that I can go ahead and take this power and just put it right in front. I've got to prove that, so I don't want to put that arrow there, but that's what I'm trying to prove. Okay, so first thing I did was then, this one's a little different than the previous ones. I'm going to raise both powers, so I'm going to turn it exponential first. So a to the m equals x, just like we did on the other ones. But what's different is I'm going to take both powers, both sides, and raise them to the b. If I do it to one side, I can do it to the other. My exponents rules say if I have a power raised to a power, I just go ahead and multiply that. Okay, so I just now what I'm going to do is turn it back into logarithmic. Okay, so now convert back to logarithmic form. Okay, which means this becomes the base of my logarithm. All right, the answer becomes the argument, and the m plus n becomes the equals. Okay, so I becomes the answer here. So when I write this, I write log base a of my argument x to the b equals m times b. Okay, again, you might want to just check it. I always have a little bit harder time going from exponential to logarithmic, but if I just throw that visual in there for you, a to the m times b equals x to the b. That turns it right back in there, so I can see that I did convert it to logarithmic correctly. And now you can see that this is the left or the right hand side, right? This is exactly the same as this, and we have m times b, but we called, and I'm just going to write that b times m because multiplication is commutative, we called m log base a of x. So I have now shown that log base a of x to the b equals this b times log base a of x. All right, now that we have those proved, let's use them. All right, so let's simplify these by using our law of logs rules, and then we can evaluate them later. But right now we're just going to start with simplifying. So have the idea that you see subtraction. So that means you go ahead and just take your log base 2 of 96 over 3, and 96 divided by 3 is 32. So we have simplified this to log base 2 of 32. Now, there is a very common mistake people generally make when they're doing this. This is not log base 2 of 96 divided by log base 2 of 3. So you're not writing this. I'm going to put it up here, and then I'm going to erase it right away. There's a very big difference between taking two logs and dividing versus taking the arguments and having it be division. You do not write log base 2 of 96 divided by log base 2 of 3. Okay, so try to stay away from that common mistake. Now we could evaluate that if we want, because if that equals x, turn it exponential, 2 to the x equals 32, and we ask ourselves what power of 2 gives us 32? And our answer is 5. All right, here we can do the same thing here. I get to move that 2 up. So I can write as log base 4 of 8 squared, not times 2, 8 squared, which is the same thing as log base 4 of 64. Again, if we wanted to evaluate, we could loop it. But let's just work with the properties for now. And last one, you see plus, that means you are going to multiply your arguments. So you're looking at log base 4 of 8 times 2, which is equal to log base 4 of 16. If I wanted to evaluate, loop it, 4 to the x equals 16. This answer is just 2. Just direction said just simplify, but if we want to evaluate, we can go one step further. All right, same sort of question here. We want to just use, you see the plus sign, so you should think multiplication. So log base 6 of 36. All right, same thing here. Got another extra step. We have a plus and a minus, so that means let's read it like we would a book. We're going to multiply here first, so that's going to be log base 7 of 8 times 5 minus log base 7 of 2, and then because you see the minus, so we have log base 7 of 40 minus log base 7 of 2. Minus means divide, so then we would go ahead and do 40 divided by 2, and our answer is just log base 7 of 20. So the missing value they want here is 20. Now you can do this all in one step. I just wanted to pull it apart so you could see what I was doing. So if I do 8 times 5 divided by 2 right away, all right. So if I just see, oh, I can just go ahead and multiply those together, divide by the 2, you're still going to end up with the 20. I just wanted to take it step by step so you could see what I was doing. All right, same thing here. Again, if you've got this, practice and then restart it and make sure you got the right answer. So this is just going to be log base 2, 7 divided by 3 times 5. And so 7 divided by 3 times 5 is just going to be log base 2 of 35 thirds, which doesn't happen to be a nice number, so my answer is just 35 thirds. Okay, try another one. The power rule tells me I'm going to do that. And you need to do that exponents before multiplication, just like you kind of learned PEMDAS, right? We need to make sure we do exponents before multiplication. So then I have log base 5 of 16 plus log base 5 of 3. And because of the plus sign, we know that means multiply 16 and 3 together, and that ends up with 48. So we have log base 5 of 48. So we're just practicing using these laws so we can evaluate things later. Give you one more here. Stop, pause, see if you get the right answer. All right, hopefully you got log base 8 of 25 halves. If not, look back at my notes and make sure you see how it's done. Again, you have to do your exponents first.